So in previous session, we saw that we were not able to query that particular NFT module. So I have done a fix for that. Actually, when we go into app.go, we can see that this particular thing over here, NFT.app module basic was commented here in the new basic manager. So it was not actually calling the particular NFT module. So for that, I've just uncommented some more commented code over here in module.go. So we have just uncommented that particular thing over here. Here it is. It's validate Genesis, and default Genesis state. And when we did our make install, and when we did our make install and we moved our binary, now when we query Comdex Q NFTs, we can see the particular two queries which we have created in the previous session are visible here, NFT and owner NFT. So if we go and query particular NFT, and it will ask for denom ID and NFT ID, and in for owner NFT, what it will ask owner and denom ID, what we have previously defined. NFT, denom ID and owner. Okay. So this is how we have completed our query section, and the remaining thing what we need to understand is the handler part. Okay. So I'm just closing all the tabs. Okay, done. And also minimizing it. So if we go into this particular thing, particular module, NFT module, and we see in Keeper, we have our own message server.go. But in message server, this message server cannot be called directly, as we need to implement handler uh, handler handler changes in handler.go, and here is how we do it. So whenever our message type, whenever we are hitting on any transactions, it has a particular message type. For example, it can be create NFT, update denom, create denom, anything. It has its own particular message. So whenever any transaction comes in this new handler, it it has a switch case, and the message is then switched according to its type. So if we have the type of create denom, then it will be going through that particular query message server function, that's create denom. Then for create NFT, it will go through particular message server, that is for create denom, it's create denom, update denom, transfer denom, and for NFT minting, that's and mint NFT. So if we see, we have a list of functions. Let me count how many are there. Burn NFT, transfer NFT, mint NFT, transfer denom, create denom. 1, 2, 3, 4, 5, 6. Okay. And if we say in proto, index NFT, and then tx.proto, we have all these 6 transactions well defined here: create denom, update, transfer, mint, and everything is well defined. I I see here over handler, we haven't defined anything. So we need to define all the transactions in handler, and also in types, we need to update it. We need to add them in codec as well, so that it's implemented. Its type is implemented. Okay, but right now I see nothing is being added here. Also, if we go to nft.go, new NFT, okay, it's well defined. Everything is defined. Okay, fine. So simply we'll go over handler, and what we'll do, switch message, and we'll create our own case. Okay, case, it's types, sorry, types dot message. Let me see that transaction. Message create them. Okay, it's directly create them. Okay, we need to define the types over here. Okay. Okay, the types is already imported here, NFT types, and here is a message create done on. I've got message create done on. Okay, and for that particular case, what we'll do, we'll have a response and a error for that particular message server. We also need to create a message server. Okay, so how can we create it is, before return we will create our message server. Okay, not new message server mutations and pass and k. So our new message server is created, and through this new message server, call simply that function create denom. And in create denom, as we have already seen, we need to wrap the SDK context. And let's see, X. And the context is passed. Then what else we need to do? We need to add in the message here. Okay, it's done. Now what we'll do? Return not null error. What we'll do? We'll wrap the service result and then return it. SDK dot wrap service result. Okay, and in that, what we'll do? We'll pass in context, response, and error. Context, response, and error. So this is how we have created a handler for that particular message create denom. Simply what we can do, we can copy paste and create it for all the 6 other transactions that we have predefined in our modules. 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, and one more 6. So one was create denom, the other was message update denom. So it will be update denom. The third one was transfer, I guess. Message transfer denom, and it will be transfer denom, then create NFT, mint NFT, sorry. Message mint NFT, mint NFT. Then we have transfer NFT, message transfer NFT, and then we have transfer NFT function here. And the last one was burn NFT, I guess. Message burn NFT. Okay, here it is. And here we have burn NFT. So yes, uh, our handler is completed. Now our transactions will go through this particular handler and will be routed to each particular functions through their message type, of what message type we are being, what particular message type we are hitting through our RPCs. And through this particular handler, they will be rerouted to the specific functions. Okay. Now we need to create the codec and update the codecs. Okay. In codec, what we have register amino codec. So we'll just remove this line and we'll register our own codec cdc dot register content. And here we have our own message type and for that particular message type, what its type is, uh, and co-ops, amino concrete options, that will be nil, I guess. Okay. So I have message. The first one was message create denom. Okay. Message create denom, and it's under the module NFT. The name should be NFT slash create denom. Denom and co-ops will be nil. So our first thing is done. Similarly, we'll into 3, 4, 5. For message create denom is done. Message update denom. Simply what we can do, we'll just write this name only. Message update denom, message update denom. And then what was that? Transfer denom. Sorry. Message transfer denom. Then create NFT message. Create message mint NFT. Sorry. Okay, one more was transfer. Then mint NFT. Sorry. Mint NFT. And then transfer NFT message transfer NFT. And the last one was burn NFT, I guess. Message burn NFT. So our codec is also well defined, register implications. So okay, everything is fine here. What we can do here, register implications, implementation, sorry. In register implementations, we can add all our types. The first one was message create denom. Okay. And similarly, we'll copy paste for every other thing. So our register implementations function is also done. So the codec part is also done. We don't need to do anything else here. So in a way, our complete NFT module is done. So what next? So once we have completed our module and everything is well defined here. So the other aspect for creating a module is its upgradation, like how we are going to upgrade it or do any changes. If in future I need to add any other field, how will I migrate this particular store, or how I will add one more function or add one more query and have it there in just a second. We can find this code. Okay, hey Dieter, I'll just push this and we will share the repository with you guys through our channels and other mediums. You'll find this code. Okay. So what I was saying, sorry, I missed your text. So what I was saying, the other aspect for any module creation is how you are going to update it, or how you are going to like add any new features or add any new struct or anything. So that is done through a Cosmos SDK upgrade. So now how upgrade is written, I will not deep diving into how upgrade is done on the chain level, but right now I'm just explaining how upgrade is written and how we are doing any upgrades. Okay. So when we go in our app.go and when we scroll down, we will see any register upgrade handlers and upgrade handlers. Okay, here it is. Okay, right now we can see we have our own upgrade handlers and we have register upgrade handlers. So for creating any upgrade, what we need to do, we need to create a upgrade plan. In that plan we have our own specific upgrade name that and also an upgrade handler for that particular upgrade. And through that, whenever a chain reaches, okay, I'm telling little bit details about how the upgrade is done in process. So we create a plan, and what we do, like, yes, I need to do a software upgrade on my particular Cosmos or Comdex chain. So how will I proceed? For example, my new feature branch is already completed and I have tested it. Now I need to add it to my main branch in which the chain is running. And I also want to update my chain. So what I'll do, I'll just do a Cosmos SDK upgrade. So how it's done, I'm showing you. Condex TX Gov. It's in Gov module and it's submit proposal. In submit proposal, we'll see a list of proposals, what we can do. And then we'll have a software upgrade. Okay, here it is. You'll see a software upgrade. So we need to define in the name of that software upgrade. What is the name? What is the upgrade height? On what height we are planning to upgrade? And what is the info for that upgrade? Everything is well defined. Let me show you a dummy thing, this thing. Simply, if I go to Mint Scan, it is an explorer for all Cosmos SDK based chain. And I go to this particular Cosmos. Okay. Here we can see for upgrades, let me see. Okay, first let me tell you the blocks. Okay, right now the current block height for Atom is 15.937806, means 15,937,807. It's the current block height. And if we want to do any upgrade, it will be in future, right? So we are planning to upgrade on something like after 100 blocks. So what we'll do, we'll create a upgrade plan for that particular block. Suppose it's 7810, and we will plan for next after 100 blocks, so it will be 8812, something like that. And when that particular block arrives, what happens, uh, the chain is halted for that period and it searches for the binary version. Like, if we are going to upgrade this chain, the upgraded chain binary is present there or not. And if all the validators are running on that specific version and all are producing and all the validators are ready to produce block on that particular version, then after the upgrade, new blocks are started to produce on that particular binary. Now whenever we are updating anything and we are generating our binary state is changed, right? So for that particular, like for example, if we are in version 1, then we'll move to version 2 after 100 blocks. So after the chain is halted on height 100, it will search for Comdex binary version 2, right? And if it's not there, the chain will fail to start again. If even if we try to start it again and again, it will show the same error, like, yes, the version detected is of lower version, we need higher version or this specific version to upgrade and to produce block. So here we can see simply say Codex version. Here it's hack v15 or anything. Okay. So what I'll do, I'll try to create a plan and show you how it's done. So in app.go, we have something called upgrades in app directory, and we have mainnet if we want to upgrade the mainnet. Also, we have something called testnet. So in mainnet, we have constants and we have upgrades. These two things are the main functions. Okay. And in that particular upgrade, what we need to change, everything is defined here. First, let me explain this, how this works. So we have created a upgrade plan, and in that plan we have taken the name or given the name for that particular upgrade as upgrade name as 11.5.0. So if we go to app.go and see, here we can see it's only up to 11.4 and its upgraded name is 11.4. So 11.4, okay, then, and it is for testnet. So we are only upgrading testnet for that particular version, not mainnet. And what we can do alternatively, what here, instead of testnet version, we can have our own version created and our own version name, and we can have our own handler, everything. So also here, it's a switch case. So you can see either if we are running it on a testnet, then our testnet upgrade will happen, or either if we want to do a mainnet upgrade and we are passing in the parameters for mainnet, then a mainnet upgrade will take place. For mainnet, it's 11.5, and for testnet, it's 11.4. So we can have multiple versions, one for devnet also, anything which we want. And we created a upgrade handler. Here we have created an upgrade handler and everything is well defined here. So what I'll do, I'll create one more testnet version. A new directory is created. V12. Okay. V12. I think, okay. And we need to define our constant and our upgrade handler. And also upgrade.go. So in constant.go, we can simply copy paste it. These are the specific info for any server specifications which we are running. So here, instead of 11.4.0, we'll remove and replace it with 12.0.0. That's done. Upgrade is constant file is created. And now in upgrade, what we need to do, we just need to define this particular thing. We'll just simply copy paste it and update its name. Right now, we don't need anything, any changes in our asset modules, so we'll just remove it and create upgrade handler V12. Okay, it's done. We don't need any updates in this particular thing. So after we have created our own upgrade handler, what we need to do, what we need to do is just go into app.go. Here it is. Import our directory. It's not TV 11.4, it's TV 12. Just refactoring it a little bit. Testnet and then V12. It's done. Okay. Now I need to create a new switch case. tv12 dot upgrade name, and it will be tv12 dot upgrade name and tv12 dot the upgrade handler v12, and we don't need a asset keeper there, and it's done. And only one more case is remaining for upgrade handlers. It's tv12 dot upgrade name upgrade. We don't need to add anything here in this particular upgrade, so we're just keeping it empty. We are not upgrading any store here, so we are just keeping it empty. So this is how my upgrade is written. So before running any update or any upgrade, what you need to do, you need to add all your features there. Mind it, you don't have to change anything in Proto. Else what you will face whenever you are querying or running any transaction, it may lead to failure, because the previously saved state is not of the previous type that was there, because you have updated it. So what we will do, will not do any proto related changes. And if we are doing any proto related changes, then what we have to do, we have to do a store migration of that particular KV store. That's a very vast topic. I don't think any one of you will need it for this particular hackathon, because it's done on live chain, which is already running and in production, and we don't have any other option, and we need to update or change the struct of that particular type. Then we need to do a store migration, and we also need to increase the module number for that particular module. So that's particular completely new thing and different thing. But if you are adding a new feature or adding in new proto, adding it new proto, not updating it, or adding in any functions, any query, what you can do is simply, or refactoring your code, you can simply perform an upgrade, and this is how your upgrade code is written. And what you need to do, just do a store Cosmos SDK software upgrade. And when the block height is reached, you just need to replace the bandwidth. That's it. Pretty straightforward. And then restart the chain. That's how it's done. So that was it for the NFT module and its upgrade.